What's up, y'all? Welcome to the video. Today we're continuing the Souls-like combat series with some basic logic for our first boss fight. In the last video, we left off with implementing our target locking system, as well as adding some improvements to our dodge animations and locomotion for the player. Without further ado, let's get right into this. Firstly, before we get into messing with the AI, I wanted to quickly make a fix from last video that I forgot to add in. So in most Souls-like games, players get invincibility to a degree when they are in the middle of dodging an attack. And while we did update stuff in our player class with the new evasive component, we forgot to make a check in the combat component for determining whether the entity will take damage. So I made sure to add this to our combat component CPP at the top of the handle damage method. Now getting into the design of our boss's logic here, we have three different types of attacks that our boss can execute: a melee swipe, a jump attack, and a roar. Each of these can be executed during different combat scenarios. For instance, if the player is too far away, a jump attack can help close the distance, or if the player is way too close, a roar can get players away. Aside from those, close and mid distances can call for a basic swipe attack. All of these check one common value, and that is the distance between the boss and the player. And there are a lot of different conditions we can add in to help add to the complexity of our boss, but to keep things simple, for this tutorial we're going to have this help dictate which attacks our boss executes. And with that said, let's get into putting together everything for our boss that we already have, and then we can begin filling in the blanks to match our design. Now in Unreal, we're first going to create our behavior tree, blackboard, and AI controller. If we go into trees and boards, we're going to create a new artificial intelligence blackboard. Call this BB, boss BB. Go in there and save it. And then we're going to do the same for our behavior tree. BT, boss BT. Open that up, and we're going to link that to our boss blackboard. Now we're going to make our AI controller. Go down here into C++ classes under /, create a new blueprint class based on enemy controller. Go into / here, AI controllers, and what we're going to name this is BP boss controller. Oops. And we're going to select our new boss behavior tree in this component, in the behavior tree component. Compile and save that. And with those now initialized, we're now going to go and create our character class for our boss. We'll just call this BP boss. Open that up. And we're going to go into our AI controller here. We're going to select BP boss controller. So our behavior is now linked, and in the mesh here, we're going to select our mutant. Select the proper anim class for it. Bring him down a little bit here. Should be good. Rotate 90 degrees. Perfect. Now we're going to go and add the different components that we need for our boss, and that's going to include our combat component. And we can fill this in a second, but we're also going to need to add a widget for the target locking. So add a new widget, just call this target lock. Go into our widget class. Lock UI, scale this down just a bit. Let's go 0.2. That should be fine. And then we're also going to have to go and add in replace the material with the one we made last time. So now it is see-through. Okay, now to fill in these combat component values. So firstly, we're going to start and fill out our attack map. We're going to have 3 attacks here. First one is going to be our swipe. Our jump. And our roar. Just match the names here. And the swipe is going to be using the mutant swiping montage. Jump is going to be using the mutant jumping montage. Mutant jump attack montage. And the roar is going to use the roaring montage. Our max health is probably going to be something around, let's start it off at 500. We're not going to have a hurt montage because our boss is pretty tanky right here, so he's just going to tank hits until you pretty much get him to 0 health. But there's going to be a death montage, so we're going to do mutant dying. Compile and save that, and we should be all set to start putting together our behavior. Looking at our blackboard here, we're first going to match our simple enemy's behavior, and then we'll begin to expand from there. So first we're going to make a new key for a vector, and that's going to be our target location. And we'll make another one that's going to be a boolean, and it's going to be is player in range. Going back into our behavior tree here, we're going to pick a selector, pick our sequence node. We're going to attach our is player in range service. That'll be the is player in range key right there. We're going to have our attack, our find player location, and our chase player. The attack we're going to use is going to be first our swipe. We're going to be checking for his player in range, target location, and target location right here, what we pass into find player location and chase player. Now before I go and test that, I just want to make a reminder that in your montages, if you want to track damage, you need to make sure you're putting in the different notifies that we made in previous videos for generating hit capsules. I already went ahead and did these for each of our boss's attacks, and I even went and created some simple VFX for some extra flair. But if you forget on how to do that, you can go back and watch those videos right now. Now testing this, we have our boss plopped in right over here, and if we go and hit play, he is moving very quickly, and the lock UI needs to be configured properly, but let's see if we can attack here. Looks like we can. Let's see if damage works. Yep, working. So if we go into our boss, we're going to take our widget here. Get the widget. We're going to cast this to a target lock UI. Or casts. Yep, there we go. Lock UI. And we're going to set the owning actor to self. That should be all set now too, and we can also go into a character movement and reduce the speed a little bit so he's not constantly sprinting at us. Go from 600 to about 300. And lastly, our boss is also very small, so let's try to scale that up a little bit too. Let's take our mesh and actually just scale everything up by about 2. Let's see how that all looks. And he's not attacking us anymore. That is because we probably have to mess with the values in our behavior tree so that he can properly attack us now that we're all skilled. So if we go back into our behavior trees, player in range, we can check, just to be safe, let's check 200. And let's go make sure that our capsule is not too off. And make sure that he's not starting in the ground. Perfect. Okay. And now he has the basic behavior that all normal enemies should have. Now with that basic setup there, let's get into expanding on our logic for adding in our different attacks. In our behavior tree here, we're going to add in some new attack nodes. So first, we're actually going to rename this to swipe, just so that the different nodes are differentiable. Our swipe attack here, we have our jump attack here. And we have our Aurora attack. Set the key. Now, this is all fine and dandy, but now we have an issue. How is the tree supposed to decide which attacks to choose from? And to answer this, what we're going to need to add in here is a decorator node. These nodes are basically treated as conditionals within the tree, and when paired with our selector nodes, we can use them to decide which attacks we want. So as our design needs to check distance between the boss and the player, let's make a decorator node for checking that. Looking at some code here, in our header file, we're first going to need some values for our far range and our near range. We'll be checking whether the player is within these two values when implementing our logic. And lastly, we're going to need an override for calculate raw condition value. We're just going to take in the behavior tree component and node memory. Looking at the CPP here, we're going to first change our node name here in the constructor and add these includes at the top. And in our calculation method, we're first going to ensure that the base use of this method succeeds. We'll then get the distance between the player and the boss, and we'll return the Boolean condition for indicating whether or not the player falls within the given ranges. And now with that decorator node made, let's switch up our logic here in the tree. So for these three attacks, we're going to separate the attack stuff and our movement right here. So what we're going to do is we're going to create a selector node, and we're going to connect these three. And then we're actually going to make a sequence node, connect it to the selector, and connect all of our movement stuff over here. So now our movement is separated from our attack selections. And how we're going to have our selector node decide what they're going to do with all of this, we're going to add our decorator node, and this is distance to player. I'm going to put it on all of these different attacks. And for our swipe, we want our near range to be around 200. And yeah, we'll have the far distance be 500. And for the jump attack, we'll have that be between 500 and 800 to give us some longer range there. And for the roar attack, it's going to be between 0 and 200. So if the player is right on top of them, constantly getting a bunch of attacks, the roar will try to get them off of them. And with those different conditionals checked, the selector node is going to first go down into swipe, check, okay, are you between this range? No? Okay, I'm gonna go check the next one. Are you within this range? If it's yes, then okay, I'm going to attack here, and then it'll go through another check once it iterates through the tree again. But with all of that worked out, we should be able to go and test. But before we go and do that, I'm going to check this player range service. We want to make sure that this is up to a higher number within all of our ranges, because given the attack nodes are checking is player in range, we're just going to check the general range and then have these really determine whether or not they're going to attack. But this is general checking if you can attack at all, and so we're just going to keep this at high range so it applies to all of these attacks. And we also want to make sure that on our attack nodes, the is player in range blackboard key is set to these, because if it is not set to those, then we're not going to attack, because the check is going to fail when they go to run this node. Now going to test this. Just get rid of some of these enemies here so they're out of the way. And we see his jump attack is going, but he's not really going up in the air like we would want him to. We're gonna have a fix for that, but first let's check the other attacks are working. Good, it's the low to mid range. Let's make sure he roars. Perfect, so the distances are checking correctly and the attacks are executing as they should. Now the reason why we aren't getting any height on our animation here is because our animation is using root motion, and in this animation the root is not actually having an upward movement, it is just going through the typical motion, and it's not really going anywhere. And the way we can fix that is with a new notify state, which we're going to add on the timeline here, which is going to move our mesh here on a curve. And so we're going to get into the code for that right now. Looking at our header here, what we're going to need is a reference to the curve we want our boss to move along, and this is going to specifically be a vector curve. We'll also want some values here for us to configure how far we want to move in the forward, upward, and rightward directions. And lastly, for our public section, we're going to need to override the notify begin and notify tick methods. We'll also have a private variable here for storing the total duration of our notify state. Looking at the CPP, in our notify begin, the only thing we're going to need to do is set the duration variable to the total duration that is passed in, and we'll be using that value in our tick method. Inside the tick method, we're going to get the location of the actor, the vector that is currently on the curve at the given timestamp in the notify state, and the actor's rotation. From there, we're going to calculate the different directions to move and then combine them. Lastly, we're going to teleport the actor offset from its current position while maintaining its rotation. The reason we're calling the teleport method is because while a root motion is active, we're unable to use certain methods such as set actor location or anything to do with the movement component because the animation is overriding that. So using this method is one way we could force our actor to move while in the middle of the animation. Now back in the editor, I've already gone ahead and made a folder for holding different curves, and I already made a curve as well and I just named it curve. But if you want to create a new curve, you're just going to right click and go to miscellaneous, and then you can make a new curve, and then from there it'll ask you, do you want this to be a float, a linear color, or a vector? We chose to go with the vector, but since this is already made, I'm just going to show you what it is looking like. If we open this up right here, we show that we have 3 different axes that we can move our values upon on the curve. For this, we're not going to move the Y value at all because we don't really want to go sideways. For our X, we do want to move forward a little bit, so we are going to have it go up to about a quarter or a little less than that of the full curve. And we want our Z component right here, which is going to move us upward. We want that to move the most, and so we're having that shoot up and then taper down as far as the location is going, and we're going to have that key go up to the max height over here. And now back in our montage, we can now add our jump curve notify state. So if we right click, go to add notify state, ANS jump curve. We're going to first, I don't want this firing in the editor, but I'm gonna go find the point where he's about to start jumping. So right about where I started it. And then we're going to end it about where he's landing. So right around here. In this notify state, we're going to pass in a reference to our curve. We want our height to be, let's have this value be about 80. And the forward, since this is multiplied by a smaller number, we want it to still go forward a little bit. So we're gonna try 300. And if we now go and test that, we should now be able to see some movement in our character. And as you can see, he is now jumping towards us properly. And he's covering a lot of distance. So if we are further away from him, he's actually going to properly move and try to get the jump on us. So there are a few things to fix with this current logic to make the boss better, but before we get into that, I'm going to go over how we can trigger the start to our boss fight and not just have them rush us upon starting the game. What we're going to need are 2 classes, a boss manager class and a boss trigger class, which will communicate with the manager and send it information for beginning boss fights. Firstly, before we do any of this, we'll need to make some edits to our boss controller and behavior tree for toggling whether or not the boss can run through its logic. In our blackboard, we've added a new boolean key called isActive, and in the behavior tree, here we have a decorator node on the main sequence, checking if that boolean key has been set. Without that key being set, the boss will not move or attack or do anything really. It's not going to run through its logic. Now looking at our controller, in the enemy controller class, we've created a new method for setting the activity of the AI. And inside this method, we are simply setting and clearing the boolean key, which for the purposes of this tutorial, I have hard-coded to be named isActive. Now with that functionality being set for us to call, getting into the boss manager, in the header, we're going to need a class reference to the UI we'll be setting for our boss's health bar. And in order to work with the user widgets in C++ for Unreal, we're going to need to use this include. We're also going to need some readable properties for the active boss, the boss's name, and whether or not there is an active fight. We'll also need a reference to the health bar we'll be instantiating and some methods for starting and ending the fight. now looking at our CPP, we're only going to need to implement the start boss fight and end boss fight methods. Inside start boss fight, we'll first check that there is a boss set to start the fight. We'll then get that boss's AI controller, and if that is valid, we'll continue. From there, we'll set the boss to be active and update the manager's state to also be active. And lastly, we'll instantiate our boss's health bar widget and add it to our viewport. In the end boss fight method, we're just going to clean up our reference to the active boss and state of the manager, and we're going to remove the health bar widget from our viewport. That's going to cover what we need for the manager. Now we need to create the class to trigger those methods. In the boss trigger header, we're going to need a U-box component, which is going to serve as a trigger collider for indicating when our fight should start. So when we add the trigger into the scene, if the player walks into the bounds of this trigger box, then we'll start the boss fight. Along with that, we're going to need a reference to the boss we're starting a fight with and what we'd like to name the boss. Lastly, we'll need a method to call when an overlap event is triggered within our box component. Looking at the CPP of the trigger here, in its constructor, we're going to set up the initialization of our component and bind our overlap method call to the component begin overlap event. Inside of our overlap method here, we're going to make sure that references to both the boss and the overlapping actor are valid. From there, we'll get a reference to our boss manager, which we'll get as an actor from within the scene. And if there isn't already a boss fight active, we're going to set the needed properties in the manager and begin the boss fight. And now putting those together, we're going to go into our CPP classes, and we're going to find a boss manager. We're going to make a blueprint class based on this. We'll just call this BP boss manager. And we'll put this in /blueprints. That should be good, and then we'll do the same thing for our boss trigger. Call this BP boss trigger, /blueprints. Alrighty, now looking in our blueprints here, we're going to drag out our boss manager. And what we're going to need is a boss bar UI, which we'll make in a second here, but we're first going to make our trigger here. And just so we can activate the boss fight itself. So if we go and we resize our trigger to be kind of like a little door, so if our player crosses through it, makes the boss fight. And what we can do is we can set our boss to be BP boss. And we'll just name this Crystal Skin Abomination. Something cool like that. And so as you see, if we start this, the boss is not moving whatsoever. But as soon as we walk through the trigger, now the boss starts and it can start attacking us. So now that we have this working, we can now go and make our boss bar UI and then pass that reference into the boss manager so that we can get some visualization of our boss's health and its name. So to make this UI widget, we're going to right click, go to user interface, make widget blueprint, user widget, call this BP boss bar. Going to drag out our canvas panel, and first thing we're going to do is we're going to drag out our progress bar, which is going to serve as the health bar. We'll anchor this to the bottom middle. Just a 0, 0. And we'll set the size to be about 1,000, maybe 1,200, maybe -600. And the size is fine. We'll set the position to 200, maybe -150, so it's a little bit towards the bottom of the screen. That should be fine. And for the text, this is going to be where our boss's name is. We're going to size this to the content, and that should be fine now. So if we compile and save that, that should be good. We're going to change the color of the boss bar to be more like a darkish reddish color. Should be fine. And now that we have this set, this should be all that we need for the design aspect of the UI. So now we can go and add some bindings to the graph section and get the actual progress of the health bar and the actual name of the boss here. Starting with the progress bar, we're going to go into %bind, create a binding. Just rename this to boss health. What we're going to do is we're going to get an actor of class. We're going to get our boss manager. We're going to get our active boss. We're going to try to get component of class, or component by class. And we're going to get their combat component. And if this is valid, we're going to get the combat component's health and divide it by their max health. Divide that, and then that binding should be all set. Now for the text here, we can add a binding here. I'm just going to rename this to boss name. And we're going to pretty much do the same thing we did with the boss health. We're going to get an actor of class. Going to get our boss manager. And we're going to get the boss's name. Convert that to string or to text. And that binding should be all set now. Now, if we go into our boss manager here, and we pass in this reference to our boss bar UI, and we go and we test that, as soon as we trigger the boss fight, we should now have this here. And now we have the health depleting as it should. So now that we've implemented the start of our boss fights, we can now go and make some additions to our boss's logic to make its behavior feel a little bit better. One thing you may have noticed with how it currently looks is that some of the attacks that should face the player aren't exactly facing the player before they're executed. So we can make a new behavior tree task node for making our AI turn to face the player and then call that before actually attacking. The header for this node is going to be just like our other behavior tree tasks, but we're also going to add the rate at which we rotate. And this value is going to be between 0 and 1, as it's going to be treated as a percentage between where our current rotation is and where our target rotation is. In the CPP for this node, we're first going to include these headers. We'll get the player pawn and the combat component of the AI. If the AI is not currently attacking, we'll calculate the new rotation and then set that to be the AI actor's rotation. Now back in the editor, let's go and make some edits to our behavior tree here. So first, what we can do is where we are setting these distance checks and our attacks right here in the selected node, we're actually just going to pull out a sequence node. Right here, move the distance check to the sequence. And then pull out here, turn to face target. And we're actually going to set this look rotation rate to be 1 because we want the turn rate to be almost instantaneous. And so now that we have that set, we're going to do the same exact thing for the jump attack, but we're not going to do it for roar because the AI doesn't really need to turn to face the player when they're roaring. It's just going to be something that they're doing to generally get them away from all angles. So we're just going to leave it for these two. So let's do that for the second one, the jump attack. Pull that here, move the distance check to the sequence. Turn to face target. And something else we can do here that may make things a little bit more clean as well is that on the jump attack, to give our players a little bit of time in between attacks, especially after one that would cause a decent amount of damage and also cover a lot of distance, to give them some breathing room after they commit a jump attack, we could add a little weight here. Maybe add a 2-second timer with a 1-second random deviation, so it could be between 1 to 3 seconds. And that should be looking pretty good. So now if we go and test that, we can see how that's feeling. And now giving that a test, let's see here. Get these guys out of the way. And he did turn to face us before he jumped. A little bit of a wait afterwards. Turn to face us before swiping. Starting to walk towards us. And once he becomes in range to jump, do that. And if he roars, doesn't necessarily turn to face us because he doesn't need to. But if I'm within the swiping range, he's going to turn before he swipes every time. Now another thing we could do to make this boss fight a bit better is we could change the boss's movement speed at different ranges of the player's location. If the player is far away, make the boss run a little bit faster to cover more distance, and if the player is within a decent range, let them stay at their normal pace. For this, we're going to make another behavior tree task node. For the header of this node, it's again going to be just like the other task nodes, but this node is going to have a property for what the new movement speed of the AI is going to be. In the CPP, we're going to need these includes and set the node name in the constructor. What we're going to do here in the task execution is cast our AI pawn to a character. If that check is valid, we'll get the character movement component and then set the maximum walk speed to be the new speed. With that now made, now looking back in our behavior tree here, what we're going to do is we're actually going to make another sequence node, but this is actually going to be above our main selector here. So if we make a sequence here, add that, we're going to add a new branch of the tree, suppose. And we're going to add our change speed. Change speed here. And the new speed is going to be 300. And the other one's going to be 600. And luckily, since we already have a distance check decorator node for checking these types of things, we can actually just add these to the different change speed tasks and then have that determine which speed is going to be set. So if we add those here for 300, if we want it to be the normal pace, we can have it be between 0 and 800, since that is the typical distance they'll have to be within attacking range of, but anything past that to, let's just say, give it a big number, say 4,000, then the boss is going to be running at them. And one thing to check here is also in this sequence, we're going to need another selector node here to actually decide between these two. So we're not just constantly checking these at the same time because we need to choose one or the other for both of these. And so now if we go and test that, some dude's going at a decent pace right there, but if we go further away from him, you'll see he is now sprinting at us to try and make up as much distance as possible. So that is going to cover our boss's logic for this tutorial, but one last thing we need to do is implement the death notify for our boss. In the header file, it's going to be just like our other anim notifies and include a function for when the notify is signaled. In the CVB here, we're going to get the AI owner and the player. If the player is target locked, we'll check who the target locked actor is and disable the lock if still locked onto our boss. This is how it should be for normal enemies as well. We'll then get the boss manager, and if that's valid, we'll end the boss fight and then destroy the actor. And once you have that notified made, make sure that you put that on the timeline for the death montage. Right here we have an Aeon defeat boss, and I'm putting it around frame 130, but it's pretty much just going to be executed towards the end of the animation. And now if we set our health to the boss super low and then go and test, we should now be able to see how this is looking. He's going to do his initial jump. We're going to go and we're going to instantly kill him. And then after that montage notify is hit, the actor is destroyed, the boss UI is taken out because that is coming from the end boss fight method. And if we walk through the trigger again, nothing else should be happening. And our boss is officially defeated. So there you have it. We now have our first boss fight using the systems we've developed thus far in this tutorial series, and we've added some new behaviors for adding to the complexity of our AI's logic. That's going to be it for this tutorial. In the next video, I'll cover how we can implement a system similar to how Dark Souls does their healing flasks, so that we can heal the player in the middle of combat. As always, thank you so much for watching, and I'll see you in the next video.